We are young citizens of the world.
We are concerned about the future of our planet and particularly about plastic pollution of the oceans.
Out of sight, out of mind. The plastic people throw away is not degraded fast enough. It is blown by wind or washed away by rain or floods to the river and then the sea. It is estimated that 5 to 13 tons of plastic waste reach our oceans each year from giant gyres, for example, the size of France in the North Pacific, or break up into tiny particles invisible to the eye.
We asked ourselves questions and looked for answers about the current situation. We discovered that there is a new method which could very well prove very effective.
Yes, it's all about using bacteria to devour the plastic in our oceans.
What are the different stages of the natural degradation of plastic in the sea?
When plastic reaches the sea, it is first broken down into smaller pieces by factors such as waves, temperature, and UV rays. This takes time. Bacteria then attack these fragments in a process known as biological degradation.
How do these bacteria degrade plastic?
A study was carried out in 2011 by Professor Alex Sivan's team from Ben Gurion University in Israel. To make it simple, we need two elements: a bacterium named Rhodococcus rubber C208. This bacterium found in the seawaters is 1,000 times smaller than a louse, and polyethylene or PE, one of the most common plastics found in the sea.
Amazing! How can such a tiny microorganism degrade long-lasting plastic?
It can indeed. Look. First, place a fragment of polyethylene in a test tube containing a culture of Rhodococcus rubber C208 bacteria. Then, incubate the tube for 30 days while regularly observing the piece of plastic under the microscope.
What can you observe?
Rhodococcus rubber C208 very quickly adheres to polyethylene, and after just 3 days, a biofilm, that is to say, a bacterial mat on plastic, can be observed. After 30 days, 8% of the plastic has disappeared.
Impressive! But how do bacteria devour plastic?
They release enzymes into the liquid environment. These enzymes act like scissors, cutting the polyethylene molecules and breaking the plastic into tiny particles. Rhodococcus rubber C208 bacteria then use these particles to feed and multiply.
So, would you say we have found the miracle solution?
Unfortunately not, or at least not yet. There is a huge quantity of plastic in our oceans. So, several strategies will be needed, but it's a promising lead. Yes! Now there is a glimmer of hope for our oceans. The hope of a cleanup which will ensure the future of all forms of life on the blue planet.